Welcome to this deep focus explainer session. Now, if you've ever felt that sudden, sharp spike of exam anxiety when staring down a massive, complex calculus problem, you are in the exact right place today. Go ahead and take a breath. Today, we are calmly and methodically deconstructing Section 2.4, Differentiation. Specifically, we're looking at the product and quotient rules for Cambridge AS and A-level mathematics 9709. The difference between a B and an A-star grade often just comes down to recognizing exactly when to use these formulas and the structural discipline you apply to them on the page. I am going to show you exactly what Cambridge examiners are looking for, step by step, allowing you to walk into that exam room with total, absolute serenity. So let's settle in and get focused. Here is our roadmap for today. We'll start with core principles, move into our procedural framework, uncover the secret of method marks, navigate through examiner warnings, and finish with the evaluative polish. Section 1. Core Theoretical Principles, Building the Architectural Foundation. Let's ground ourselves here. To start, I just want you to keep the number 3 in your mind. Cambridge prioritizes 3 distinct cognitive domains when marking calculus questions specifically. It's so important to realize that the assessment framework isn't just trying to trick you with hard numbers. It's actually demanding analytical depth over superficial breadth. Think of it as a 3-layered foundation. If you only have one layer, the whole structure wobbles. These are the 3 specific cognitive targets you absolutely must hit: knowledge and understanding, application to problems, and logical analytical reasoning. It's not enough to just memorize the formulas. We all know the quotient rule song, right? But you need to recognize that the product rule applies when 2 functions are multiplied together, and the quotient rule is strictly required when they are divided. But let's look at this through the lens of 2 different types of students. Imagine we have 2 scholars in our virtual study space right now. We'll call them Alex and Sam. Now, Alex is incredibly analytical. Alex maps out the textbook definitions perfectly, nailing that first bullet point, knowledge and understanding. But then we have Sam. Sam is dynamic, maybe a bit more creative, and naturally jumps straight to the second point, trying to apply it to the problem right away. What Cambridge wants is for you to merge both of these approaches using that third bullet point: logical, analytical reasoning. You must understand how the rules interact with the specific problem in front of you, without rushing. And that brings us to conceptual understanding. This is the mastery of connected mathematical principles that can be successfully transferred to unfamiliar exam contexts. It's like a giant puzzle. Mastery means taking the product or quotient rule and successfully transferring that knowledge to completely weird, unexpected exam contexts. You aren't just solving a standard algebraic fraction here. You are demonstrating an elite, highly adaptable skill set. If they throw a natural log inside a trigonometric function, inside a fraction, you don't panic. You just rely on your conceptual understanding to break it down. Remember this, because it's absolutely crucial. Principal examiner reports specifically highlight that bringing in cross-topic connections is your clear, undeniable path to achieving those higher tier marks. For example, you might be using the quotient rule to find the gradient of a tangent on a really complex trigonometric curve. Integrating these concepts, pulling from geometry and calculus simultaneously, signals to the examiner that you have achieved true mastery. You aren't just a robot doing algebra, you're a mathematician connecting the dots. Moving on to Section 2, Structured Procedural Framework, Finding Your Exam Flow. Let's establish that rhythm. When you look at a daunting past paper question involving the product or quotient rule, you need a systematic way to process it without freezing mid-question. So I want you to follow this standardized 5-step sequence mechanically and methodically. First, identify the key elements. Literally isolate the assessment objectives demanded by the prompt. Second, apply the relevant mathematical principles. Third, execute your calculus with absolute clarity in your working. Fourth, verify your results. And finally, present everything in the appropriate format. Let's bring Alex and Sam back into this. Imagine they're working together to assemble a model response. Alex maps out step 1 and 2 perfectly, defining U and V. But Sam challenges the framework, saying, hey, we need to make sure step 5 actually links back to what the question asked. They debate the layout, writing out their sentences to perfectly fit the mark scheme parameters. This 5-step flow is what keeps your argument blocks structured, so you never run out of time or lose your place. To execute step 1 effectively, we perform what I like to call the mindful scan. Before writing a single number on the page, take a 60-second visual countdown. Just breathe. Strictly extract the functions, identify if they require the product or quotient rule, and figure out exactly what the prompt is demanding. Peel back the filler words. It is a moment of deep, intentional focus before the execution. Extract, interpret, conclude. Let's transition to Section 3, Securing Crucial Method Marks. This is your psychological safety net. Now, what's really interesting about this slide is the sheer relief it offers. This quote directly from the Cambridge Examiner report says, students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. Just think about that for a second. The process itself proves your analytical reasoning. When you use the quotient rule, calmly and explicitly write out your u, write out your v, and calculate your derivatives du and dv right there on the paper. If you happen to mess up the final algebraic simplification because you dropped a negative sign, guess what? You still capture the vast majority of the points. That is your psychological safety net in action. By contrasting these two approaches, we see exactly how structural discipline prevents marks from slipping away. A high-scoring response is incredibly logical, proving step-by-step reasoning with those cross-topic connections we talked about. A low-scoring response? Well, it might miraculously have the right final answer, but with zero visible working out, it earns 0 method marks. Imagine Sam rushing through, doing the derivatives in their head and just writing the final fraction. The examiner looks at it, sees one tiny error, and gives it a 0. Now imagine Alex, who wrote every single step. The examiner sees the brain on the page, awards the method marks, and Alex walks away with the points. You have to make your thinking visible. Okay, let's pause. Just breathe for a moment. We're halfway through, and I want to make sure we do an intentional focus reboot. Before we move on to write out our final top fan paragraph structures and look at exact examiner warnings, ensure your daily study dashboard is complete. Subscribe to Ace the Exams right now and enable all notification alerts. Whether your target is an IGCSE, an O-level, or an AS and A-level A-star, this space is your weekly hub for stress-free exam mastery. So hit that bell, refocus your mind, and let's get back into the flow. Section 4, Top 3 Examiner Warnings, Navigating the Practice Arena. Let's look at where things go wrong. Entering the practice arena, we must calmly confront the top 3 specific pitfalls identified by principal examiners for this exact section. First, answers are often far too vague. The examiners want highly specific algebraic details. Second, candidates forget to check format and presentation conventions. And third, solutions are not specifically linked to the given context. Let's say you encounter a structural roadblock mid-problem, where your evidence drops out of alignment. If it's an application of differentiation to find a stationary point, your final answer needs to clearly state those coordinate values. You can't just leave it sitting there as a floating x value. You must remain mindful of these 3 errors to ensure full examiner compliance. Use this simple visual check as an intentional reboot during your exam. Clear step-by-step lines, correct algebraic terminology, and clear annotations like dy by dx equals are not optional. They are strict conventions. If your page looks crowded or unstructured, if it looks like a chaotic web of numbers, pause, breathe. Restore balance to your text. Use clear structural frameworks. A clean, aesthetically pleasing layout on your page usually reflects a clean, logical thought process in your mind. Visual satisfaction actually helps you think better. Finally, Section 5, the final evaluative polish. This is your master review pass. By viewing this clean structural framework, you can see how advancing from simply describing calculus to actually evaluating alternatives completely locks in your grade. At level 1, descriptive, you're just stating principles. At level 2, analytical, you are executing clear working, which, as we know, secures those essential method marks. But at level 3, the evaluative stage, this is the highest order assessment objective, advancing from simply applying a formula to actually justifying your mathematical decisions with solid evidence is what elevates a good answer into a flawless one. It guarantees your response precisely aligns with the very top band of the mark scheme. Top-scoring candidates never just stop at the math. They demonstrate higher-order evaluative thinking by addressing these critical elements. They check their domain limits. They verify whether a stationary point is actually a maximum or a minimum rather than just assuming it. They question the assumptions made in the model, and they justify their final coordinate decisions with absolute rock-solid algebraic proof. When dealing with differentiation applications, proving your mathematical model is robust, line by line, is exactly what secures that A-star. It's about having the final word on the problem. As our focus meter maxes out for this session, I want you to remember these three core pillars. They will systematically guide you through literally any high tariff differentiation problem Cambridge can throw at you. First, the three-step mindful scan to decode the functions and peel back the filler. Second, the marks per minute flow, that step-by-step procedural sequence that guarantees your method marks. And third, the final evaluative polish review pass to lock in the top band. Print these pillars in your mind. Thank you for joining this deep focus explainer. I want you to subscribe to Ace the Exams and click the notification bell for future focus deployments. And right now, leave a comment below identifying the specific subject, tier, and target grade you are currently calmly pursuing next. Keep your focus sharp, trust your structural frameworks, and we will see you in the next strategy session.